And we're live. Okay. What a pleasant noise. Hello all. Hello world. This is day 153. I'm on the wrong screen. I was studying compilers every day until I landed a compiler role. Last time we started building out spilling a little bit, I think. Or at least we did like spill weights, and then we started like scaffolding out what like spill all would look like. This time I don't know how much time I have, because I have like homework to do low-key, and it's due like midnight, so I should get that done. But hopefully we can get some of spill built out. Maybe just like some of the visitors, maybe, or at least figure out how to structure it, and then it's just like very boilerplate from there. And then we should be pretty good to go actually. Yeah. So let's get straight into it. I clicked the wrong window. NT. Let's see. Yeah, so we scaffolded that stuff out last time. Hopefully we can finish up most of it. So specifically this little pile. So yeah, let's see how we go about doing this. I think the book had some pretty good stuff. The big things we need to worry about are first figuring out where it goes on the stack, and then second, once we have like where it is on stack, we can, I guess, generate loads and stores from there around things, and it will be good. Yeah, okay. Where am I looking right now? Okay. Let's look at advanced compiler design and implementation. I actually hate Acrobat. This is not an enjoyable PDF reader. Let's go here. Let's keep clicking through this. All right, zoom in a little bit more. Is this walking through an example? I think this is walking through an example. Yeah, okay. So I definitely clicked too far. Maybe it's here? Spilling. Ah, wait, I see. Let's see where the explanation is. Something register pressure, the number of colors need to color an interference graph, okay. Modifications to code, reducing register pressure. That makes sense. The effect of spilling is to split a web into two or more webs and to distribute interferences. It seems... that's... Okay, that makes sense. Replaced by 4 new webs. Okay, that makes sense. And then we can like recolor at least, but I don't really think that changes a lot actually, given the way we've implemented things actually. So this is a little bit more complex than I was hoping it would be, because we're not really. Yeah, because we kind of have like a pile of temporaries still. Yeah, so this code might suck sometimes. Yeah. Yeah, actually, that's kind of awkward to think about now that I think about it. Generate or compiler regalloc. Generating spill code. What is like a good way of doing this at least? Let's look at the CMU lecture notes. Yeah, this makes sense so far. Yeah, how do we want to do this? We could like, we could treat it as like live range splitting, but I don't know. This is giving me a lot more headache than I initially thought about. Where's the part where it talks about spilling, at least? Does this talk about webs? It does not. Okay, yeah. Yeah, okay, so we do coloring, that's fine. What does that mean? Ah, I see. That's what that means. Okay, pre-coloring. This is like the other thing I was thinking about. Let's see how I did it correctly. Calling convention. Oh, I actually should pre-color now that I think about it. Yeah, that's interesting. I definitely should do that. Let's see. Regella, important phase, information, something about appel. Spill. It is polynomial, isn't it? I've got news for you. Does this talk about spilling anywhere? Does it? I guess it doesn't. Okay. Anything interesting here? I want to see if there's a way I could do this without like encoding like live ranges again, or at least like webs at least. I'm not really sure how to generate spill code beyond that point. At least is the concern. Okay, this mic arm needs to suck less. Anything readable here? That doesn't help. Okay, and it's just a proof. Okay. I guess I probably shouldn't be looking at papers to figure out what I'm doing to begin with. Let's look at this article about Go. Maybe we can learn something from this. We should have used SSA. We should have kept SSA. That would have made my life easier. Oh well. Okay, that doesn't say a lot for me. Maybe something here? Hopefully there's something here. It is impossible to fit 5 gallons into a 4-gallon container, so we are out of luck. That's true. It's a funny way to word it, at least. Something about heuristic. That's fine. So I guess do we just like, would we have to like spill like, I guess, R minus N plus 1 registers, I guess? if they're like kicking each other out. I guess that's how we would think about it, maybe. That's very annoying. Maybe I'm just thinking about it wrong, actually. We probably do need to spill like 2. Spill whatever we are currently dealing with. True. Okay, so we do like a stack location. Oh, actually we can encode that very nicely. Okay. Current interval with the interval that has the latest endpoint. Oh, I see. This is the heuristic, right? Are we generating code at all, or? I guess we could just try naively spilling and then we'll see how badly it goes. I don't really know if I can like reason through this very well, at least. So, yeah. Okay, well, I guess we could look at this maybe. What language is this? Is this OCaml? I don't think this is OCaml. Oh, it is OCaml. Okay, cool. OCaml follows me everywhere. Okay, yeah, so those are our registers. Yeah, this goes over intervals. Good to see you again, Scottish. Still learning C++? That's good to hear. I saw you were like making some good progress. I think something else you could maybe think about is just like try to like make a basic program of some sort, and then anything you don't know how to do, you like read up on, and then like you read up on like the theory that surrounds it. So like, for instance, just like Hello World. So like, the first question is like, how do you make a program, right? So then like you read about like the C++ like program structure. You learn that like main exists, and then like all that sort of basic stuff. And then once you get to like the point where you're printing, like literally printing Hello World, then you're like, okay, how do I print? So then like that's where you learn about like std_cout, and then like there you learn about like headers, and then like how all that stuff sort of works. And then from there like you kind of just like keep building on top of it like that. That's at least like how I've been thinking about learning, at least. But your mileage may vary. I personally find it's like a more active way of engaging with the content rather than just like whatchamacallit, rather than just like simply just like following like a set track, because then like you definitely remember what you're learning because you're actively working with it, at least. Okay. So I guess we could look for the live range of whatever we're trying to spill. Let's see. How do we want to do this? I guess we could just print interference somewhere here, maybe, in like regalloc, and we can see what happens. I always wanted to create a programming language. How much do I need to know to be ready for that? I'm gonna be honest, I don't really know. I think that's kind of something you have to figure out yourself. Maybe like you could probably like start learning about like different features in a language, and then like from there you can kind of just like figure out what you need to know. But you have to be like very self-directed with that. I can't really give you like a concrete answer because like it literally does depend, at least. Finally landed a role related to my skills. I'm so nervous. I start the 17th. Ooh. Oh, congrats. I imagine you'll do great. You made it, and you made it into the role for a reason. So I imagine it will be a-okay. Okay, let's do this. Let's break here as well, just as like a temporary measure. Yeah. How many languages do you know? I've like worked with like 10 or 12, I think. Probably like 10 if I had to guess, but if you ask me how many I'm comfortable with, the number changes from time to time. I don't really think I'm like fully comfortable in any of them. Like you don't need to like, there's not like a very clear line where like once you know a certain amount, you're good to go. It's more just like the more you know, the more intuition you will have for some things, but like it's not something I can really quantify for you. Our operator is basically the same across most languages. To some degree, yeah. There's just like a different way of writing it in a lot. It's like, in like some Lisp-like languages. So like Racket is the big one everyone thinks about. Like whenever, if you look at like Racket code, you see like instead of seeing like 1 + 1, you see like +1 1 in like braces, for instance. And it's like the same idea. It's just like it looks a little different. What the hell? Yeah, okay. That's my little spiel at least. That doesn't, okay, 01. What's something that we 100% need to spill? Special learn operators in C++. I think, I don't know. I think you're thinking too much about like what the correct path is. I think you should just like learn whatever feels right at least. I don't think it's possible to like very completely learn everything at the same time. So just like, I think it helps to like learn little bits of things incrementally and then figure it out from there. Like I genuinely think you're just trying to like, or without like trying to like put words in your mouth, it feels a lot like you're trying to, I guess, like science the learning a lot. And I think that's cooking too hard at least. Okay, which example here would cause a problem? Scope maybe? No, that's fine. Do any of these have to spill? Surely one of these does. Okay, like where are we spilling? Do any of these spill? I hope one of these spills. Oh wait, I remember now. It was call chain 0. This function should spill, I think. Yeah, okay. Okay. What was I trying to do this for again? I was trying to think about how we would reason about this. Okay, so 91. Where does 91 live? There it is. So this is like we are running out of registers, it feels like, if I'm not mistaken. So what are we doing with this? I guess, how do we figure out what to do with 91 here? Yeah, how do we reconcile this live range? This feels awkward. Something tells me we colored something incorrectly, and I'm not sure where we colored something incorrectly. But I think we colored something incorrectly somewhere. Yeah, this is rough. What would you say your skill level now is in compilers? I don't have a good way of gauging that, honestly. I don't think like, the field is so large. It's very hard for me to determine, at least, where I am. Yeah, this is... I'm not really sure what I'm trying to do here. Let's move something into 91 and then from 91. Yeah. I'm not sure. I'm not really sure what's happening here. What's good, BM? I'm kind of stuck. I feel like I don't really know what to do from here. Yeah, for reference, we're like here. Is this Regilock? Yeah. So I think I did something wrong. I'm pretty certain I did something wrong here. I'm not really sure what, but I think I did something wrong. Are you doing internships? Yes. That is the goal. Yeah, I'm not... Something is off. I guess maybe we should print the stack then, I guess. Let's look at... Where did I do this coloring? Right? Was this where this lives? God damn it. Yeah, okay. I guess... Let's go up to... I guess here. So we have like this move to stack thing. So you should just print remaining? Not remaining. Pruned reges. Yeah, okay, so we do use it down there. What type is this again? This is a vector, okay. We want... Oh wait, reg to string. We'll just do this for now. Let's do that. Yeah, this is very readable. This is 100% a readable slush pile. Okay, I might have made a mistake with that. Let's actually just go to the test instead. Just comment that out. Oh, okay, so I guess we can't comment that out. We probably need better error handling, but that's a future concern. Maybe let's make many reg.c. Let's just make some stupid test. Let's make like fn. What am I doing? What is this? Rust Okay, so int a. We'll just do something stupid here. I don't know. You know what? Here's what we're gonna do. Let's do this. ChatGPT. Yeah. Extend this out to every letter of the alphabet. Why should I write the test code when we can let ChatGPT write some very heinous shit right now? Make it return z plus y plus ... I'm sure this will be fun to read and definitely won't cause me issues later down the line. What am I doing? Okay, let's steal that. Oh god. Okay, well, okay, this has to spill something. This 100% has to 100% has to spill something. Yeah, okay, so let's give it many reg. Okay, this might have been a regrettable choice in hindsight, because now I have to scroll through this. Okay, let's actually maybe we don't do that. Let's just do just grep. I mean, the problem is I have to go up. Yeah, don't worry about what's happening here. Okay, maybe this is not gonna be something I can read actually. So let's not try to read this. Let's not try to read the 16,000 lines of code. Limit available registers. Oh, I see what you're saying. Yeah, okay. I'm gonna keep this test around because I feel like it will be useful in the future, but let's do 4, maybe. Is this all we have here? Maybe we do, let's do 2 registers. Let's make build. Let's not do many reg. Let's do square. There we go. Or wait. This might be too simple. Let's look in tests again. What would be good here? Oh, this scope thing probably would be good actually. Making textures through a maze runner is harder than coding? I guess that makes sense. It's like a different skill set altogether, so I mean... Wait. O0? Does this do it? Huh. Huh. Something's wrong. Something might be wrong. So what is my code doing? This is a little bit scary. Something tells me something is wrong. What version of Windows 11 are you using? I don't know. I don't really care what Windows version, to be honest, because I'm just sitting on WSL. Something seems wrong. How the hell do I debug this, actually? Genuinely, how do I debug this? Also, just out of curiosity, what does many reg do with opt? Okay, fair enough. Okay, curiosity satisfied. Okay. Yeah, I don't know what to do here. I guess we could think through this logic more explicitly. Oh, okay, so this is just for degree. Wait. Huh, wait. Okay, I think there's a mismatch here. I think that is what is going wrong. I think I know what to do. First, let's make this a const real quick. Or something. Or const expr. I don't know. I don't think it matters here. Okay, let's drop down to here. Specifically the coloring after we've done all the pruning. Okay, so here, we get something. We have neighbor colors. So here we get all of the colors of each neighbor that we have right now. Okay, so this just adds all of the neighbor colors that we've seen so far. And then, what are we doing here? Oh, available colors, I see. Okay, so we're stepping through that. Maybe we just print available colors at the end and we see what happens? Or wait. Oh, it's because we built our interference graph with everything. Okay. So here's what we're gonna do. We're just gonna... So this is the new color. Okay, so if we haven't found it, wait, what the hell is happening here? Okay, so this walks through the colors we have so far. And we find the lowest one. And we assign it. If it doesn't exist, then we haven't found it. So if it's a virtual register, we give up. Here we include the if available color size. So if this is equal to num reges, then I guess we just continue, or we think we just continue here. I think that's fine. Yeah, let's do that. Or make build. Build? Build. Okay. Let's do this again. Okay, now we're spilling, or attempting to spill. Okay, so there's all the physical registers, and then EDI is here. What the hell? Wait, why is EDI here? Wait, what the? Did I forget to convert sized? Is that what happened? Wait, what? How do I compile C++? What do you mean? Like, how do you build Clang, or like, how do you run? You might have to include. I think it was like, it's like std C++ or something like that. I don't remember exactly, because I'm just sitting on CMake, but yeah, you need to include the standard library. There was like a flag for it. Okay, so it gave up here. So something is wrong here, I think. I suspect something is wrong here. How do you deal with CMake? Let's see. You just like set up a bunch of like CMake list slush. So you make a project, you set some stuff. And then in sources like the stuff I actually make, I think I lied. Let's look at driver. This might be the most useful. So you add an executable, or like, yeah. So like you add an executable, you like add the libraries that you're linking. And then like CMake does all the generation for you. If we look at build in the make file, is there like a nice little Clang thing here, or GCC, CC? That's not it. Maybe it's in here? Alright, sure it's in driver. One of the function arguments would be in EDI. Oh, I see. That makes sense. Oh, wait, I need to worry about liveness for... I see. Okay, I'll worry about that in a second. Let me figure out where this stuff lives. Is it in here? Okay, well I can't seem to find it because I don't know how to navigate around makefile or CMake slush. But yeah, you could definitely just look up like which flag it is to include the standard library. Do you not use Telescope? I'm lazy, and I don't know what to look for in Telescope at least. I also think my Telescope just doesn't work on git ignored directories, which would include build. Yeah, I have Telescope. I have Telescope. I'm just lazy. Okay, what do we do about function args actually? This is annoying. This is very annoying. I think I'm just treating... Okay, wait. Let's look at the liveness output, actually. I think this will give a lot of hints. Yeah, we need to worry about size when making the interference graph, I think. But I think we do that, right? That shouldn't be a problem. Right? Maybe we just forgot to size things properly. Okay, let's look at interfere. Get size registers. So then, what the hell? Oh, wait, I see. So you do just include all of them. All of the sized registers. This seems inefficient. This seems incorrect, at least. But we do need to like encode the size somewhere, right? For some instructions. Ah. This is giving me a headache. So we do that there. I guess we're just literally doing all the possible registers, which, like, fair enough. Wait. Fair enough. Wait. Wait, something is wrong. What the hell? Wait, what? Okay. So why are just these 32-bit registers here? Let's print interference now, I guess. Zoop, okay. Yeah, so those exist, but none of the other size registers are showing up. Strange. I feel like when testing it, I explicitly included all of them. I mean, obviously that would cause a problem here. Maybe like the wires got crossed somewhere, and I decided somewhere to not include them. Oh. Yeah, I did explicitly decide to not include them. Okay. What was my... Yeah, the problem here is I don't want to include them because that's just like more correct, I feel like. But if I include all the sized register, it shouldn't cause a problem. Grr. It feels incorrect to include them. But I feel like I need to like keep them around for like size. It should be encoded in the instruction, right? We're not keeping enough information around. Okay, let's look at our instructions real quick. I think we keep enough information. Let's look at the header. So label, we don't care. Move has source size and dest size. I think that's fine. Push, we have a size. Pop, we have a size. Convert is fine. We don't care about that. Binary op. They're assumed to be the same size. Special op. What the hell are we doing with this? I guess we could just look at the op, maybe. I don't know. What instances do we have of special op at least? Is it just like division? Is that literally it? Oh, it's in tile. Yeah, that's it. Oh, this is off screen. Whoops. So this is in tile trees. Okay, so what is size and wait, what the? Oh, I see. Okay, yeah. Okay, so I think we can very implicitly determine the size here at least. LEA, I think we kind of just eat shit and figure out what size we need things to be in. Or at least it doesn't affect dest and source. I think we're kind of just only using LEA for optimizations instead of like actual like address computation. So I guess that kind of works out. Comp here I think is fine. Oh, we might need to encode size here. Do we need to though? I feel like we do. We might just need to like refactor all of like our comparison stuff eventually. This is very annoying. We should probably encode the sizes. I think that would be smart. Or maybe encode a size in like the virtual registers actually. I feel like that would be... I should probably do that. But then that doesn't solve the problem with the physical registers. I don't know. Jump we don't care about. C jump we don't care about. Call we don't care about. Virtual call. This is a problem, I think. Yeah. Okay, so we need to like keep sizes around somewhere, I think, if we're not gonna... Or I guess in general we just need to better represent sizes. Oh, what a headache. Can we just assume everything... We can assume everything virtual is 32-bit for now. Okay. I don't know. This was so stupid. Why did I decide ints were fine? Why did I think this would be a fun time? I'm regretting so many choices. Yeah, address arithmetic is not gonna be great. This sucks. This really sucks. How do we encode sizes properly? What do we do? What do we do here? Yeah, maybe our virtual registers should be sized. I think that's a good first thing we need to do. This was a mistake. I think from there it'll be fine because then we can kind of just like re-walk the original function, but like, oh my god. Okay, I'm gonna write this down. I think I'll mull it over later on. Yeah, so we want to add sizes to virtual registers. Size and kind, I see. Yeah, that would make sense. Let's Luckily, I don't have to worry about floating point yet until like when I decide that I should implement it and then give myself more headache. So we're actually just gonna kick the can on that and not worry about that for now, until we have like a catastrophic bug. But it'll make good stream content when the time comes. And I will remember this conversation, so I will, I will definitely remember it. So I will definitely, when the stream time comes, I will remember to look here. Okay, so we should add sizes, and then we can like just rewalk. I guess if we're like doing replacement anyway, we can just like convert things into size anyway. I think that's fine. Yeah, that should be fine. Yeah, and then we have to encode that somehow in some other place. What else do we need? So once we have that, how does that change what we have at least? I think the plan is I'll just think this through right now, and then I think I will just like encode it properly next time. Or as in like I will do the legwork next time. So this print interference. Well, how does this affect liveness at least? Okay, that means we can deduplicate a lot of stuff. We can just like keep it as one size of registers instead of worrying about 64 and 32, I guess. I think we already do something similar in liveness. Let's actually just comment that out. Let's run that back. RSP EDI, yeah. So we do worry about sizes here, but that's fine. We can just like, I think we can just like sterilize all of this in one place. I don't know where. Where do we want to sterilize this? Do we want to like flatten all of them in liveness? RSP like T13, yep. Yeah. This is the same RSP. Okay, I think we leave it the same here. Yeah, it is literally like 213. This is it's assembly, but like we haven't actually made the registers yet, so we have these like fake variable like registers. Yeah, okay. So I think we should leave it as is in liveness, I think. Let's rebuild. And then we have this vomited out output. Yeah, so we should sterilize it in here. So we get rid of like this little awkward snippet thing. Yeah, so this interferes with EDI where it should, I guess it would interfere with what, RDI? Yeah. So yeah, there's in fact no 0 here. I think that's actually the cause of all of my issues. So let's just like flatten in interference. Yeah, I think that's fine. And then like once we, and then how does this affect spill code? I guess register assignment and spilling would walk. But then we give it coloring. Right? How do we assign registers again? Coloring. Let's look at it on the left side. Cool. Okay. So we're looking at assign registers. We have assignment visitor. Oh, we literally look at the instruction. Wait, we're fine. Yeah. Yeah, okay, this is fine. Because we just, like, we feed it the operand. So we can just yoink the size from that. And then reuse the size, I guess. So that would be fine for assignment. I imagine it would be similar for, like, generating spill code as well. In a similar sense. Surely this is fine. Yeah, okay, this is... this has not been as much progress as I would have liked, but I guess this is all useful for the future. Anything else I can do in the meantime? Yeah. So then when we could think through just like how we spill it. Yeah, how do we want to spill a register? That seems awkward. Yeah, I regret not like I regret simplifying too soon actually. This is a mistake. I should have just done like SSA destruction and just like worked with an instead of like going too far down to assembly. I should have kept like some notion of like a load and store in this IR, I think. But I don't know if I don't know if it's worth it to just like add that back. That feels like kind of awkward, at least. I guess we could look at like MOV in that way as well. Yeah, we could handle liveness for MOV differently if it's like an address actually. I think that also might be something that breaks our liveness a little bit. No, that should be fine actually. I don't think that's a problem. I imagine that's like already accounted for in our gen and kill, right? Maybe I'm just like seeing ghosts right now, but yeah, I'm definitely just seeing ghosts, I think. Yeah, this... So check operand. What language are you building? I am literally just working with a subset of C. But I'm making a compiler for it from C to x86-64. Yeah, we actually got ghosts in the machine. For this address. Oh wait, this might be borking. Okay. No, this is fine. This is fine. This is definitely fine. Yeah, okay. We're fine. We're fine. This is fine. This is all fine. Everything's fine. I don't think our liveness is wrong at a glance. I don't think it was. Maybe we didn't account for like... Did we account for the stack variables properly? Let's just uncomment this. Why did you choose C++? Because I wanted to get more practice with C++. If I were to like do this without caring about C++ practice, I would have just done Rust. This looks fine. I guess this makes sense. This is all like propagated to the top. Okay, so EDI we don't care. Why C++ practice though? Because all the jobs I'm looking at for the most part, they probably require like strong C++ knowledge at least. Or at least if I'm looking at like the quant space specifically. Okay, so in, or this doesn't change, that's fine. Here, move 0 into that, or reg 0 into that. Ambulance. Yeah, this looks fine. Here we keep 5. Yeah, that makes sense. Which compiler should I use? Clang. We love Clang. Or GCC. It's up to you. Clang is, Clang might be a lot faster, but I don't know. That's just from like the little 20 seconds of debugging I did. If it compiles, it compiles. So this is fine. This is fine. Yeah, okay. This is O0, so we don't have very high register pressure. We keep 7, yeah. Okay, this seems reasonable enough. Okay, okay, I see. Okay. So from here, I guess we can just generate live ranges. What am I saying? Wait. Hold up. Okay, I'm like going insane. Maybe I guess when we're spilling, we could just like spill one live range instead of spilling the entire variable, and that would be sane. What do you think of OSDev? I think it is something I admire a lot. Yeah, I've always not felt cracked enough to do OS stuff, because I thought I was thinking about a lot of stuff, and then it turns out like OS devs have to think about like so many more things, and then on top of that, like I think malicious input is, or like adversarial / malicious input is even more of a concern. Because like it turns out you don't really have to idiot proof a lot with a compiler, because like, at least in my opinion, I feel like usually we're like expecting like the worst that happens is like you generate some like stupid code and like it doesn't work and like someone gets mad at you. But, like in OSDev, like if you mess up really bad, like the worst that happens is like data gets stolen and like actual bad things in the tangible world happen. Let me write a reminder for how I want to spill. Yeah. Yeah, so like there are like lots of like actual more material impacts that come out of like bad OS dev. So I admire them for like just the amount of glue work that they have to do, but also worrying about like just people being people as well. Yeah, okay. I also need a better way to encode this actually, because if I'm doing coalescing, this will get coalesced, EAX we get coalesced into 12, which is obviously not what we want. That's a very annoying problem. I guess we could do like a virtual ret as well, with like pre-coloring. And then like when I don't remember if we like pre-color params in a virtual call. I guess it's implicit, huh? I don't know, we'll see. It's not fine, directly compute the result in EX if possible. I see what you're saying. I think the way that I was looking at coalescing being implemented is like destination gets coalesced into source. So I guess the notion of the AX register would disappear is the problem. And I would like to avoid that, at least. I'm not sure which direction coalescing goes. I imagine like coalescing upwards is like safe. I guess there's a problem either way. Either like params disappear when coalescing, or yeah, either like the parameters disappear when coalescing, or the return value disappears when coalescing. So I need to figure out which way I want to do that. I think parameters might be... There's not a great way to... I don't know, I'll figure this out. Let me just like figure out coalesce direction with ret and params. Yeah. Okay. Well, I think that's like a good enough plan at least. I was kind of hoping we could do more spilling stuff, but obviously I hit a brick wall. Yeah, let's just clean this up, and I think I'll call it a stream soon because I need to like finish some work before class tomorrow. Let's get rid of temp. RM, that's a new one. You know what? This deserves a screenshot. This goes in stream media. RM. Yeah, that's a new one. Yeah, so let's do that. What do we change here? We can revert all of these changes, I think. Let's add these tests real quick. Many, reg, and shift alone. Okay. Yeah, I'm gonna go do homework now. Thank you all so much for showing up today. If you haven't already, make sure you sub to the channel, like the stream, the usual pile. Description, Discord, pings, better than YouTube. LinkedIn, GitHub, add if want, don't if don't. GitHub sponsors, description, money give if want. Yeah, I guess it's homework time. Take care, y'all. Take it easy, and have a wonderful rest of your day wherever you are.